Law of cosines today, and law of cosines is a little more complex. If you know the law, if you know the formula, it shouldn't be terrible. Emma, quit. Put that away. You're with me. Put it away. Yeah. So if you know the formula, it's okay. There's just a few scenarios where, again, it's very particular how you plug it into your calculator, and some of the algebra can trip people up. So I need you to really pay attention to that process, just how we plug it in, and just the rules, like PEMDAS comes into play. And so many people make a PEMDAS mistake in this problem. It's kind of reverse PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponent, multiply, divide, add, subtract. Okay, so here's how this goes. The law of cosines works with two different setups. It's the SAS and the SSS triangle that you can use the law of cosines with. Again, I just kind of look for the basic pattern that law of cosines follows. The book's going to give you 3 formulas. I'm going to give you 1 because they're all the same. It just switches where your A, B, and C are. Oops, that's not B, that's C. Okay, so if we have triangle ABC, same as yesterday, A is across from A, B is across from B, C is across from C. The law of cosines says this. It's a little lengthy. Bear with me here. It says A squared. So the length of CB squared, okay, that side squared, will equal B squared plus C squared minus 2BC cosine A. Okay, looks a little lengthy. It really isn't bad because they're all kind of repeat letters. So the thing that I'm just going to show you why, okay? Please don't write this down, because if you look down and are scribbling while I'm going through it, you're going to lose me, because it's all over the place. So you don't need to write this down. If you want to write it down later, go back and watch the video and write it down from the video. But I want you just to understand where this is coming from. And if you're trying to scribble it all, you're going to lose part of this, okay? So stick with me. Just watch what we got here. Let's say we have a triangle. Well, let's make that dotted. So this is the height of the triangle, okay? It's perpendicular. This is B, this is A, this is D, this is A, this is C, this is B. Okay, first of all, if the length of this side, the whole thing, is C, and this piece of it is X, then what is BD?
X minus.
The other way. C minus X, okay? So we're going to call that C minus X here, okay? Okay, so this is our setup. I know right now a few things. I know if I do the Pythagorean theorem that B squared, B squared is equal to X squared plus H squared. Do you see that? X squared plus H squared equals B squared. Okay, agree? You know that to be true. Okay. I also know that if I do the cosine of A right now, okay, so I'm looking from A. The cosine of A is what over what? Adjacent over hypotenuse, which is what in this setup?
Adjacent would be B, lowercase b.
X over B, right? B is your hypotenuse, so X over B. Okay, so those are just details we know to be true in this. Now what I'm going to do is I'm going to take triangle CDB, CBD, CDB, doesn't matter the order, and we're going to do the Pythagorean theorem for it. Okay, so this triangle here with the Pythagorean theorem would say that A squared is equal to C minus X squared plus H squared. Okay, it's a right triangle, so the Pythagorean theorem works. C minus x squared plus h squared should equal a squared. Do you all agree with me so far? Have I not lost you? Okay, so those are all just things that are true. Okay, do you remember how to factor c minus x squared?
Oh, cx minus cx. C minus x. I don't know.
There was a shortcut you learned in algebra. If you don't remember the shortcut, which I'm assuming most people don't, you just FOIL it.
Oh,
Okay?
that's what I'm-
But if you do remember the shortcut, life is much easier. Are any of these, any of you in here Algebra 2 also? Eric, are you Algebra 2? Yeah. Did you learn this shortcut this year? To factoring it? So you would be c squared, right, first, and then minus cx minus xc, which is cx still. And then negative x times negative x is a positive x squared. Right? So this is this. Okay? So what I'm going to do is I'm going to replace those things in the next little piece here. A squared equals, and I'm just going to take this and put it in there. So c squared minus cx, that's minus 2cx plus x squared. And then we still have the plus h squared tacked onto that. You still with me?
Yeah.
Okay.
That's too much.
Okay, we'll get back in line here. Where do you see this? X squared plus h squared in what we've done. B squared, right? That's this. So I can take this out and put in b squared. Okay? Then if you also look, we did, actually we're going to do this. We're going to solve this that we started with for x. How would I solve for x? Multiply by b. Okay? So b cosine a is equal to x. So I'm going to take out this x and I'm going to put in b cosine a. Aren't you glad you don't have to do this process every time you want to solve one of these problems?
No, my head.
Wow. Oh, so that was just the expanded
Okay.
version.
This is like how they came up with the law.
Oh.
So rather than having,
Okay.
you would have had to do this every time before these brilliant mathematicians were like, look,
Oh,
it does the same
gosh.
thing every time.
Like Shakespeare.
So this is really mad.
This is just me explaining to you why. This is the why. I'm never going to make you do that process. But then look at this. If we just rearrange now, if I bring the b squared over here, it's a squared equals b squared plus c squared minus 2. I'm just going to rearrange those. bc cosine a. That's the law of cosines. Okay? So that's how they get the law of cosines. You don't have to do that. You just have to do this. Okay? So I'm going to give you a few triangles, and we're going to do the law of cosines in those few triangles. Wait, what?
Nothing, never mind.
So it's just.
That's just a proof. That was just the proof of here's why this works. You don't, I said, don't take notes on it, just watch. You don't need to stress about that. This is what you need to be able to do. Yeah, see, if you guys would listen instead of speaking through me,
No, I thought you meant like.
you would get these things.
I thought you meant like we're gonna need to know it, but like take notes later.
No.
That's all I was like.
No, that's just for people who need the notes. If you need to have notes on it, go take the notes later. Okay, so here's our setup. With law of cosines, this would be an SAS triangle, so we can use the law of cosines. Here's the rule that you have to make sure you stick with every time. In our original setup, the angle here, A, was across from which side? The lowercase a, right? So every time, wherever your angle is, the A is across from it. Okay, in this case, that's my X. So this would be my A. your B and your C are interchangeable. So it doesn't matter if 14 is B or if 29 is B. B and C are interchangeable every single time. Okay? So we have capital A, lowercase a B, and a C, and we just need to plug that in to this formula. So it's going to be a squared, or x squared, equals b squared, 14 squared, plus c squared, 29 squared, minus 2 times 14 times 29 times the cosine of our angle A, which is 52.
It's giving me like a headache.
Just plug everything into that formula in the green.
And that's the answer.
Yes.
Once you simplify, we want to solve for x, okay?
say how you know? So what if you like A, B, C?
I did. Yeah.
So you just like add the same
Yeah.
A, the capital A is always the angle, and across from it is always the lowercase a. So lowercase a is always across from the capital A,
B and C are
okay?
add.
Okay, so here's the deal. If you paid attention to the lesson instead of doing the homework, I would explain all of it to you today.
Just taking that's hair.
Okay, so here's the setup. You're gonna take all of this and you're gonna plug it in. 14 squared plus 29 squared minus 2 times 14 times 29 cosine 52. Okay, you get x squared equals 537.082. The number keeps going. But here's the thing. When you're doing this problem, I don't even need you to write that down, because what are you going to do to that number? You're going to square root it, right? It's x squared. So we're going to square root both of those. So you're going to go second square root, second answer, which will take the square root of 537.082, and it comes out to the nearest tenth. What would you get?
23.2.
23.2. Okay?
Oh, I did a little trick.
Okay, here's the deal. That is the easy version of this, where you literally, listen, you're just taking numbers and you're dropping them into the formula, right? And then you can plug it into your calculator straight. There is nothing to solve for other than a square root at the end. Okay? Where it gets a little fancier and we tend to have a little more issue with how we plug things in is in a problem like this. This is not, I'm not trying to freak you out. I'm just trying to get you to pay attention. Just pay attention. You're going to be just fine, Michael. You always pay attention. Okay. Now it looks like this. Can you tell me what your capital A would be from our formula? X, right? So this is our capital A, which means what is our lowercase a? The 8. And that is a must. You cannot say, oh, let's use the 9 as A. It cannot be. It has to be across from the angle is your A. Okay?
So the actual angle where the degree is, that's where the capital letter is going to be, and then across it's below.
The action, say that I didn't.
So the degree, so x, degree x, right?
Yeah, X
That's
degrees.
what's gonna, the capital letter is going to be.
That's where your capital A is.
Gotcha.
Yes. Okay, so this is your setup, and again, B and C are interchangeable. So pick B and C as 9 and 5, but doesn't matter which one. I did 9 is B and 5 is C if you want to keep it consistent with mine. We are looking for an angle measure here. What do you do when you're finding an angle measure?
We use an
Inverse, okay? So you're going to use an inverse in this problem, but we got to set it up first. So I'm going to rewrite the formula so you see it right in front of you. It's a squared equals b squared plus c squared minus 2bc cosine a. You all have it memorized by now? Yeah?
Is there a little song that can go to it?
I don't have a song for this one, unfortunately. Okay, so now your job is make sure you put things in the right place. Yes?
Are we going to need to memorize it for the judge?
Please.
I haven't decided that.
No,
I think what I maybe have done in the
B
past.
squared plus C squared minus
is I've given the formulas but not told you which one it is. So I'll give you the law of sines and the law of cosines. I'll just write them out, but you need to know when to use law of sines and when to use law of cosines. I think that's what I do. What?
Minus 2b
I think you'll see, I think I put the formula on there.
Me too.
Okay, so here's your setup. A squared, what is A right now? 8. So you're saying 8 squared equals B squared, which is 9, plus C squared, that's 5 squared, minus 2 times 9 times 5 times the cosine of A. Okay. Now we're going to do a little bit of simplifying. Here's where you need to not lose me, because some of you are going to do reverse PEMDAS wrong, okay? Don't be that person.
How come it wouldn't be cosine?
Well, because
It would be cosine X. Yeah, sorry. You can put an X there. But it's the capital A, right? It's this number, not this number. It's got to be the capital A. So we'll put an X there. I'm not trying to confuse you. It's X. Okay, so if we simplify this, 8 squared is 64. But here's where the issue usually lies for people. That cannot be plugged into your calculator and you're done with it, okay? Because you are adding here, you're subtracting here, but what are you doing here?
multiplying.
Multiplying, okay? 5 times cosine X is multiplication. So you cannot right now do all the addition and subtraction before you've done the multiplication and division, right? PEMDAS says multiply and divide first and then add and subtract. So what you have to do is 9 squared plus 5 squared. Okay, so you can just plug that into your calculator. 9 squared plus 5 squared is 106.
Yeah.
Okay, and then it's minus. Now you can combine this. 2 times 9 times 5 is 90. And then you have cosine X. Okay? You cannot do 106 minus 90 right now. What do you have to do? If we're going to eventually isolate X, what do you have to do first?
Multiplication.
You have to get the cosine.
90 cosine.
Okay, but we don't know what X is, so we can't multiply 90 by cosine X.
You just send it.
Here's what you're going to do. We're going to solve for X by taking this 106 away. Okay? So you get 64 minus 106 is a negative 42. Okay? Which is okay because now if you look at the other side, you have a negative 90 cosine X. Right?
Yeah.
What's your next step algebraically?
Divide.
Take away the negative.
Divide, right? Right now we're multiplying by that negative 90, so you're going to divide by negative 90 on both sides, so this is gone. You're left with cosine X equals negative 42 divided by negative 90 is this number, 0.46 repeating, okay? Like I said, just leave that in your calculator, go second cosine, second answer, okay? Second key, cosine key, second key, answer key. I don't know what your answer key says on it. Mine says enter. No, mine says the negative sign, but whatever yours is. So you're going to go, the inverse cosine of 0.46 repeating is, oops, 62.1818 keeps going. So in degrees, and these ones, they often will tell you to round to the nearest tenth of a degree on these ones. Just pay attention to where you're being asked to round. If it says nearest tenth, round to nearest tenth. If it says nearest degree, round to the nearest degree. So this to the nearest tenth would be about 62.2 degrees. Okay? So really, the algebra is what tends to throw people off on these. Make sure if you're not clear what the algebra is supposed to be done, that you ask, okay?
So instead of doing all that, we just punch it all into our calculator, right?
you can't punch it all into your calculator because there's no x here, right? So how would you plug x in? You can't plug all of this in because this has to be multiplied before it can be added and subtracted. So instead you need to move things away from the x to isolate the x and solve that way.
Then why in the other one we were able to put it all in the
Because it's all, that has numbers everywhere. This one had numbers, right? You didn't have any variable in that whole thing. So you can plug it in. But when you have a variable on that side of your equal sign and a number on the other side with variables with numbers with your variable, you can't just plug it straight in. Okay? Okay, we're gonna do one more. And like I said, this is just a matter of making sure you're plugging things in right to get the right answer. That's probably the biggest issue on these. Okay, here's a problem for you. I'm not gonna write out the words because it's a lot of words. We're just gonna draw a picture as we go from the words. But this one can be a little tricky as to how you draw it out. So hear me as we do this, okay? It says a boat leaves port. So we're gonna call this point right here port. Okay, so that's port. A boat leaves a port and travels 1.3 kilometers due east. What is due east? Straight east, right? So if we're going straight east 1.3 kilometers, that's gonna put us here, okay? It says a second boat leaves a port and travels 1.8 kilometers heading, and here's where you need the numbers, south 22 degrees east, okay? Think about what that's saying, south and then 22 degrees east. So if we went south, straight south would be here. 22 degrees east of that is where we wanna go. So that means this angle here is 22. That boat went 1.8 kilometers. So the length of that line is 1.8. Okay? The question is, how far apart are they now? So I have 1.8 for this side. Okay, that's the 1.8. I have 1.3 for this side. And then I have this 22 degree angle here, which helps you find the angle we actually want, which is this angle, angle Y. Anyone see how you could find angle Y right now? If we went due east and due south? Who said something? 90 minus 22. So we're going to call this 90 minus 22, which is actually 68 degrees. Okay? So now you're looking at this triangle. I didn't draw that very well, sorry. This is 1.3, that's 68. This is 1.8. And we're looking for the length of that side. Okay, so first being able to set it up based on the directions they give you. And then once you have it set up, now this is one of the easy law of cosine problems, right? This is the one where you are just going to be able to plug it in. So how would we set this up? What's A? What's lowercase a? That's x. So capital A is here. And then B and C are interchangeable. So it's going to be x squared equals B squared plus C squared minus 2 times B times C times the cosine of 68. Okay, so plug that into your calculator again, just make sure you're getting it. I will plug it in also to verify your number. So if you just plug that straight in without square rooting yet, what do you get? Right, 3.1768, the number keeps going. So we're gonna square root that. Don't forget to square root it because we want to solve for x, not x squared. And that comes out to approximately, remember, second square root, second answer.
1.8.
To the nearest tenth, it would be 1.8 kilometers. Okay? Questions on that? Okay. We're gonna leave it at that. Just, I would, if I were you, refer back to this. Go watch that second example again when you do your first problem like that in the homework. Notice the difference, okay? This problem, when you're solving for the angle, that's the one where you have to be careful about how you plug everything in, okay? All right.